Today again we are going to discuss one of the most important topics in a data structure, which is queue. So queues are the data structures that are like stacks, having restrictions on where you can add and remove elements. To understand a queue, we think of the cafeteria lines. So the person at the front is served first, and the person are added at the line at the back. So thus the first person is the line is served first, and the last person is served last. It's also known as or abbreviated as first in first out, which is FIFO. So queues are often used in programming networks, operating systems, and other situations in which many different processes must share resources such as the CPU times. So one bit of terminology: the addition of an element to queue is known as in queue, and removing of element from queue is known as dequeue. Although the concept may be simple, so programming a queue is not as simple as programming a stack. So let's go back to the example of the cafeteria line. Let's say one person leaves the line, then what? Everyone in line must be step forward, right? Now imagine if only one person could move at the time, so the second person step forward to fill the space left by the first person, and then the third person step forward to fill the space left by the second person, and so on. Now imagine that no one can leave or be added to the line until everyone has stepped forward. So you can see the line will be moved very slowly. It is not difficult to program a queue that works, but it is a quite proposition to make a queue that is fast. There are the couple of the basic ways to implement a queue. The first is to just make an array and shift all the elements to accommodate in queue and dequeue. This, as we said above, is slow. So the slowness of the previous method is that with many elements, the shifting take times. That's another method. Instead of shifting the elements, we can shifting the in queue and dequeue points. Imagine that cafeteria line again. So if the front of the line continually move backward as the person leave the line, so then the people don't need to step forward or backward, which save time. Unfortunately, this method is much more complicated than the basic concepts. Instead of keeping track of just an in queue, the end, we can also keep the track of the DQ, the front. So this is all get even more complicated when we realize that after a bunch of the in queues and DQs, the line will need to wrap around the end of the array. So think of the cafeteria line. As the people enter or leave the line move farther and farther backward, and eventually it will circle the entire cafeteria and end up at its original location. So we have now let's see the implementing of a queue, and we have a source code here in the data structure in C++. So this source file is an implementation of the queue class. This class is implemented with the templates and the size is determined dynamically and at initialization, although the default is 500 elements. So the actual amount of the space allocated for the queue will be one or more elements than the defined maximum size. This is useful for implementing the queue in a circular method. So first in first out. Okay, to understand the circular implementation, think of array as a circle. When an element is dequeued, the queue doesn't shift all the elements forward to start the queue. Instead, the class shifts the start of the queue back. Eventually, the start of the queue will have shifted so far that the queue will extend it beyond the end of the array. So this is where the circular move comes in. When the queue reaches at the end of the array, it wraps around to the beginning of the array. Here we have the source code, which is very lengthy. You can screenshot it from here, and you can also screenshot it here and tell me in the comments whether you find it helpful or not. So overall summary of queue is the first in first out. You can if you imagine the cafeteria line, then you can easily understand it. It's a bit complex or bit complicated concept rather than the in stack we use LIFO, last in first out, and in queue we have considered the FIFO, first in first out, which is a bit complicated. So if the person from the middle leave the line, this is bit more complicated. So here that's it for today. Thank you.